Hello, these are your notes on section 10.2, Law of Sines. I'm going to go through these and just like I would in class, and you're going to watch these and write. I'll leave a set of notes for you to write on. You're going to, as soon as you get the notes copied down, then you can show them to Mrs. Kennedy, and she will give you the assignment to work on after this. And we'll see how long it takes, and then we'll go from there. First, let's talk about what an oblique triangle. Oblique just means not right. So if you have an oblique triangle, it means it's not a right triangle. If it's an acute triangle, it will have three angles that are acute or less than 90 degrees. If it's an obtuse triangle, it will have one angle that is more than 90 and the other two will be acute. The term solving the triangle means finding everything that's missing, every angle and every side that is missing. And just like when we solved the triangle for right triangles, there's usually, one or two things that are fairly simple to find, and then some other things that are going to require a little more work. The law of sines is a way to find missing angles and missing sides in a non-right triangle. And the law of sines says that if you take the sine of one of the angles and put it over the side across from that angle, that will be equal to the sine of a different angle over the side across from that angle, which in turn will be equal to the sine of the third angle across from the side over the side across from that angle. So we're only going to be dealing with two angles and two sides at a time, but all three will be equal if you put them into those ratios. Okay, so we're looking at this first one. First, I want you to notice that we have capital A, capital B, capital C for the vertices of this triangle. And then this is kind of a standard form. Across from capital A is the side that is marked with variable little a. And across from capital B is little b, and across from capital C is little c. Then for the angle measures, we use Greek letters alpha, beta, and gamma, which is just Greek letters A, B, and C. And just do the best you can on those. The main thing is I need you to recognize them when you see them. So alpha, beta, and gamma. And that's going to be the standard form. And there will be times when they don't even give you a picture. They will say triangle ABC, and then you have to know where little a, little b, little c goes, and where alpha, beta, and gamma go. All right. Let's look at the first example. Law of sines says that I can take the sine of the angle and put it over the side across from it. Now we're also going to have law of cosines after this, and then once we talk about both of them, we will talk about, well, when do you use law of sines and when do you use law of cosines. Basically for law of sines, if you don't have the angles and the sides you need to do them, you can't do it. So most of the time you're going to have angle, and then a side. There will be a special case that we're going to talk about in a minute, or possibly later, we'll see, that we'll have to deal with. Alright, so the first thing I want to find here, and I'm going to use this space up here, so I have all this room down here for the law of sines, but I have two angles here, and I want to find gamma, so that's going to be 180. I'm just going to put gamma equals 180 minus 33 plus 47. And so you can, if you type that in your calculator just like that, let me clear off the scratch pad here, 180 minus parentheses 33 plus 47, and so we get 100. All right. And the reason why I found that, well, we're solving this, but I'm going to need to find C, and that's the easy thing to do, but we're solving it, the triangle, so we have to find every single thing. All right, I'm going to find side A first. So we start with the angle that is across from A, and we say the sine of 33 over the side across from that is A is equal to, now I need to pick one, and don't forget we already have this, we have 100, but I don't have C, so I don't want to use that, so I'm going to use the 14 and the 47, so I'm going to say the sine of 47 over 14. Alright, so now we cross multiply. 14 sine of 33 equals a sine of 47. And then to solve for a, we're going to have to get rid of the sine of 47, so we divide by. And so a is going to equal all of this, and I put that into my calculator. Now you're going to need to make sure you are in degrees. My calculator doesn't do this, but there should be a DEG up here. I know I'm in degrees, so I'm just going to do Control Divide and get a fraction. 14 trig, choose sine 33 over trig sine 47. And then we hit enter, and I get 10.4, let's say 426. The fourth decimal is a 7, so the 425 will round up to 426. So A is equal to 10.426. They didn't give us a unit of measure on this, so we don't have to put a unit. If you want to, you can just put units. All right. So now we have A. It's 10.426. To find C, I'm going to do the same thing. C is across from the 100, so I'm going to say sine of 100 over C is equal to, and just to avoid using decimals, I'm going to use the 14 and the 47 again, so the sine of 47 over 14. Now, be careful, this formula is just two fractions made up exactly the same way, the sine of an angle divided by the side across from that angle. If you get that in your head, then you'll be okay. So here we get 14 sine of 100 equals C sine of 47. Divide by sine of 47. And C is by itself now. So if we put all this in the calculator, we're going to get the correct answer. Now if you look, 14 sine, that's changed. So the only thing that changed is the 33. So I'm going to arrow up and highlight and press enter. And then I'm just going to change that 33 to a 100. And let me double check it. 14 sine 100 sine 47. Got it. Okay, so C is going to be 18.851, but the next digit is a 7, so that'll become 852. And then, of course, that's in units. So that's 18.852. Things to look for. This is across from the 100, so this better be your biggest side. This is an obtuse triangle. If this is not your biggest side, something's wrong. Alright, and then sometimes they give you a problem where they don't give you the picture. So all you do is you just go ahead and draw the picture. Just draw a triangle. Your triangle may not look right. Don't worry about it. Now I'm looking at alpha and beta, and they're the small angles, so I'm going to put A here and B here, and then alpha here and beta here. And then this will be gamma, so or C up here for the vertex, and then gamma. All right. This is 36 degrees. This is 48 degrees. And then we know A is 8. To find A, you find capital A and go across from it, and that's 8. So here's little b and little c. And again, this is just kind of an understood when you're working with these. This is how it goes. I'm not real happy with this c right here. Okay. So again, because we have two angles, I'm going to find the missing angle first because it's super easy to do. So I'm going to do gamma is 180 minus 36 in parentheses plus 48. Let's type that in real quick. 36 plus 48. There we go. So gamma is 96 degrees. I'm going to go ahead and put this in my picture. 96. Okay, so now we're going to do the same thing we did. We're going to write law of sines to find B and C. So first we start with B, and B is across from the 48-degree angle. So the sine of 48 over B is equal to, I want to use C because I don't know it. I don't want another variable here, so I'm going to use the 8 and the 36. So the sine of 36 over 8. Again, when we started, you'll notice we have angle, angle, side again, which is good for law of sines. All right, cross multiply and you get 8 sine of 48 equals B sine of 36. We're solving for B, so we're going to divide both sides by the sine of 36. And that's going to go to 1. And so we're left with B over here, and then all of this is going to go in the calculator to find B. Okay, so control divide 8 trig sine 48 over trig sine 36. And I get 10.115. The fourth decimal is a 5, which means 114 will round up to 115. That is not what I said. 10.115. All right. Now again, they didn't give us units. So if they don't give units, I'm not going to count off if you don't put units. If they tell you that the side of the triangle is, instead of 8, they tell you it's 8 centimeters, then you're going to need to put centimeters here. Okay, so now we have that. We have B, it's 10.115. So now we're going to find C. So we say the sine of 96 over C is equal to, sine of 96 over C is equal to, and I'll go with the 36 and the 8 again. So the sine of 36 over 8, cross multiply, 8 sine of 96 equals C sine of 36, and then divide to get rid of sine of 36. And then I get C equals all of this. And again, you have this happen almost every time you're solving a triangle with law of sines. If you look, I've got 8 sine. The only thing that has changed is the 48 has become a 96. So if you don't want to type that whole thing in again, just go up, highlight it, push enter, bring it down, and then change 48 to 96. And then enter, and you get 13.535, but the fourth decimal is an 8, so that's going to round it up to 536. And that's units. All right, that is the basic idea for law of sines. You can also use it to find angles, and we'll do a little more with this, but I think I'm going to stop here today and let you work on some problems where you're finding sides. And then tomorrow we will look at some more where we're finding angles, and we'll also look at what is called the ambiguous case. So we'll do one example tomorrow where we're finding angles, and then we'll look at the ambiguous case where when you do law of sines, there's a possibility you could get 2 different answers, and we have to look at both possibilities. All right, you may now, once you've copied all of this down, you may raise your hand and show your notes to Mrs. Kennedy, and she will give you the assignment paper for today. Thanks, and I will see you tomorrow.